I will be starting shortly. Please stand by. Welcome and good morning. This is Microcontrollers with kingernorth. This is episode 29. We're going to be looking today, comparing the Feather RP2040 and the Pico RP2040 using CircuitPython. So we're going to be using CircuitPython to do our programming. So welcome everybody. And let's have a look at what we're going to be using today. So here we go. This is it. This is our good board. This is everything we got. Good morning, Walter. Welcome aboard. Brian sends his regards. He won't be able to make it today, but he'll watch this later. So today we're going to be looking at a couple of boards that use similar way of programming for both the Pico RP2040, which is this one up here, and the Feather RP2040, which use the exact same processor. They're just on a different board, different connections, and a few other little oddities, and I will be talking about that. The other beauty of this is this board is so new that I only got it 3 days ago. So I haven't even worked out everything on it yet. I'm still learning with it, and we're going to see where it takes us. We're going to compare the price, we're going to compare the features, we're going to have a look at what they can do. These are what the two boards look like when you get them. So this one here, let's get this turned around and see if we can't get it to focus on my hand. This is the Pico version. This is the Pico RP2040. This is the way you buy it. It has no headers. It has nothing. It is just this board, this tiny little board. That's a $4 US board. Typically, it's about $5 US if you get the header pins going with it, which I soldered on this one to put it in the breadboard. So that's the first thing. This is the second one. This is the brand new Feather. Now the Feather is ever so slightly larger, and I do mean slightly. It's one pin wider on a breadboard. That's all it is. But this one here has the chip on it. We'll look at the details on this in a moment. It has everything on the back. It has labels on the back. It has nice print there. It also has some standard printing that matches the Feather on the front. And I'll go over some of the differences in the features because there are some differences in these two boards. This one is about $12. It does come with the headers, and it is a little bit thicker on the edge. So it's a little bit sturdier board, but it has a few other advantages as well that may justify the difference in price to you. It depends on what you want to do with it. So let's have a look. Hopefully, Walter, I think I've got my audio figured out pretty good. I don't think we're getting any echoing today, and hopefully it's not scratchy. Can I get a thumbs up when you get a chance if that's correct? I hope it is, because I can't hear it while it's recording. So let's have a look, and we're going to go into our main screen now because I want to go in and I want to use a few of the other features. Hey, look at that. I think I finally figured out both issues I was having. And hopefully that won't be an issue anymore. Although, I must say, Windows tried to throw me a loop today. They did an update a half an hour before the show, which caused me a little bit of grief, but I got around it. So let's have a look at what we have going on in here. And the first thing I'd like to do is I'd like to have a look at some of these items closely to see what we have. So we're going to go into some pictures, and we're going to have a look here. And up here we can see we have, this is the Feather board. Now, right here in the middle, or right here, I guess not quite in the middle, to the right of center here, is you can see the Raspberry logo. This is the actual processor chip. This is the RP2040. It is the exact same chip that's on the Pico. So this part of it is not going to vary at all. Where there's some changes, and I want to point them out, is similarities and changes. Here is the memory chip. This is the QSPI memory chip. Now, on the Pico, we do have a QSPI memory chip, but it's only 2 megs. This is 8 megs. This has 4 times the storage on it. So if you were to program this board with another language like Python as opposed to CircuitPython, Python takes up about 1 meg of this space. And on a Pico, that would leave you with about 1 meg to program. On this, it would leave you 7 megs to program. Quite a bit more access to it. So it has that on here. Another common feature between the two is this button. This is the boot select button. On the Pico, it's in a different location, but it has a boot select button. The difference is this button. This does not have, this is on the Feather, and this is a soft reset. So this allows you to do a soft reset of the board without powering down and powering back up. The Pico doesn't give you that ability to do that. To do that, you add power and put it back on. One of the other differences is this connector here. This is a USB-C connector instead of a micro B connector. So this is getting to be a little more popular, and Adafruit has been using this on more of their boards, but also a lot more devices in the real world are using it, because it doesn't matter which way you plug the cable in. When you go into here, it's universal, so there is no up, there is no down. Makes it a bit easier. Something else you might have noticed is this great big plug that's here. This plug allows you to connect a battery up to it. This allows you to connect one of your LiPo batteries, either a 3.7 volt up to 4.2 volt LiPo battery into here, and this will actually charge it, and there is a charging light. If you're plugged into USB power, USB will charge the LiPo battery that you have connected to this. When it is finished charging, that light will go out. So that's just something to keep in mind. This is a yellow LED for that purpose. Another common item is this pin 13. This is marked as 13 on the stencil. This is the LED. This is similar to the Arduino Uno, has an LED in position 13. A lot of boards, because people started out with the Arduino Uno, and yeah, Windows 10, you gotta love it. But this pin 13 is the LED, and a lot of boards put this LED on position 13 because it's convenient. Now, they put an LED on the Pico, but they didn't do it to 13. They actually connected it to general purpose 25. So it is connected to a different spot, but there is an LED on that one as well. Another feature that's on here is this. This is a NeoPixel. This gives you the status of what's going on, or you can program it. And we're going to do that today. We're actually going to program this as well as a NeoPixel strip. So you're going to see how we do both. But if the features weren't enough yet, we still have another one down here. We have this one down here that's marked I2C. This is a stemma connector, an STEMMA. This allows you to connect I2C through stemma devices. So whether you're using one of the ones from SparkFun or you're using the ones from Adafruit, they have these quick connectors on the end of them, and they're very small, and they allow you to connect multiple I2C devices without actually having to use jumper wires. You just use a cable that has a plug on both ends, and you just plug them in, and they just daisy chain down the run. The other last piece about this is the Feather. They call it the Feather format because this is a standard that was created by Adafruit, but has been adopted by many other manufacturers now because they saw the popularity in it a few years ago when they started this. Is we actually have pins down this side and pins down this side, and I believe it is 16 down the bottom edge, along this bottom edge here, and we have 12 along the top edge here. And we always have the reset there. We always have the 3.3, and usually it's a 5 volt, but now it's two 3.3s. Battery enabled. We have the USB, which is the 5 volts from the USB connector. We also have a bunch of dedicated pins here, pin 13, pin 12. So there's pin 13, that's that LED. Keep that in mind. We have pin 11, 10, 9, 6, 5. We have I2C, which is the SCL and SDA. We also have on the, then we come around to this side, there's D4, another digital pin. We have receive and transmit, which are serial connections, same as the USB. We also have the M0, MI, or MO, MI, and our SCK. These three here are an SPI connection. And then we have a couple more digital pins, and then we have 4 analog pins. And all of those are in a standard layout for a Feather board. They've set this standard pretty early. What that means is we connect other boards, we can stack them on top, we can put them in side by side on doublers or whatever we want, but there are a whole pile of accessory boards that can be added to this and work with this Feather, just like they do with all the other Feathers, and they work with different brands of boards as well. There's a few different companies that are producing boards as well that use the same Feather format and pattern, so that the accessories all work from one to the next to the next to the next. It helps in your development time, and they go from OLED screens to motor drivers to any number of devices that are out there that are all connected through here, and they allow you to build on this Feather format. So this is the reason why Adafruit did this as their first RP2040. It's a common format. It's popular with everybody, and it makes sense. So they'll be coming out with a couple more 2040 boards using other formats, and we'll talk about those when they come out and see what differences they have to make to them for the different patterns. So let's have a better look at this here on the bottom. This is the bottom of the board. We can see that they've identified it as the Raspberry Pi RP2040, and it is. And we also have all of the alternate pin connection names. So on the top, we had pin 5, pin 4, we had SCK, we had all of that. Well, they're all tied because of the RP2040 and the way it works. We also have general pins, and we have here general pin 6, general pin 00010. This is 20, 19, 18, and they continue on down the line here, and then there's also a bunch more on this side. Now, the numbers don't seem to make perfect sense to what we're used to seeing, but that's okay. CircuitPython maps that for you, but you can use either name. You can use the GP name, or you could use the name that's on the front side of the board. Both will work because they're the same place. Just one is mapped through for you. So you're used to programming in CircuitPython, you can just use the normal names you would normally use. So this makes it very adaptable. You can see here they also talk about the LiPo battery connection, 3.7 volts to 4.2 volts, and it's a USB charge, which means it can charge off the USB connector while we've got it. So let's have a look at some of those features again. Processor is identical for both boards. It's a dual ARM Cortex M0. It is also running 264K on-chip SRAM in 6 independent banks, and that's because that's part of the RP2040 chip itself. Where it changes, the QSPI memory. The original was only going to come from Feather, was only going to be a 4 megabytes. They decided to make it 8 megabytes because it took the exact same physical size, and the pricing was very, very close to the same. This one has 2 megabytes of memory on a separate chip, which that QSPI chip is actually about a quarter of the size, but it increases if you go to 4 meg or larger. Connection, USB-C. Looks like I typed a 4 in there where I shouldn't have. And this one is a USB micro B. Number of connection pins. We actually have 30 connection pins on there, on this board itself. And there's 21 of them are general purpose I/O pins. On the Pico, they break out a few more pins. They don't break them out the same way, but they do break them out, and they have 43 pins in all on the board, 20 down each. 26 of them are general purpose I/O pins, but 3 of them are strictly for debugging purposes. This actually, the Feather board has a spot on the top that was marked as SWD, and it actually has a special connector you can solder in there, and then you can plug in a JTAG connector or something like that to do your debugging. So they use a different standard for doing it. They wire up the same, it's just a different way of connecting a debugging tool. Pin uses. Well, this is where we are similar but not identical. In the Feather board, we actually break out all 4 of the analog input pins for use. In the Raspberry Pi, we only use 3 of them. They only broke 3 of them out to the surface. 1 is still internal in the chip, and they actually use it for monitoring the internal temperature of the processor core. So it's actually hooked up separately, and so they actually only break out 3 to the outside board for us to use, whereas Adafruit brings all 4 out for us to use. They both have 2 UART device connections, which people like UART. It's a serial type connection, specialized. The SPI connections, which is quite popular for dedicated. It's a 3-wire serial connection. I2C is very popular, allows you to put multiple devices on a single pair of wires. And then they both actually have 16 pulse width modulation pins as well. So 16 of these pins can be configured for pulse width modulation. Adafruit just broke all of them out, whereas the Pico, there is only 16 in the chip anyways, so they could only make 16 of the chip pins accessible to that, so you have to be careful about which pins you use so that you don't get them confused. So that's what happens there. Now let's go back and look at the board. Now this is a drawing that's in the progress right now. AT Maker Bill has created this drawing. I believe he's doing it for Adafruit as well. He's doing this one for their behalf, which is really nice. And he's following a standard that was done by another person who was submitting these types of pinout drawings to Adafruit many years ago and started it at first. So what we've got here is we've got a number of items on this detail. So it shows you down here, anything in red is power. So there's battery power here, which is the same as the battery connector. There's the USB, which is tied to the USB plug. We also have the two 3.3 volt. So that's after it goes through the regulator, comes out as 3.3 volts. Up here we have our reset pin, so we can actually do an off-board reset. We have our standard ground pin. We only have one ground pin on here, unlike the Pico, which has many ground pins going around it. The analog pins are here, analog A0, A1, A2, A3, and they are connected down into this side here. There's also GPO24, GPO25, which are uncommon for the Feather, but they're usable pins for this case. Here is the SPI connection. Again, they're grouped together. This is the serial communications. This one here, if you notice the purple circle around the connection here, lines up with these. These have to do with programmable I/O banks. The way that a feature that they added when they put in the RP2040 is they created something called programmable I/O, which actually gives you a lot of flexibility. I'm just starting to learn about that. I'll do more on another show about that because it actually allows you to take some advantages of this chip that the other chips don't have. And then, of course, we've got the last two here, which is the I2C pins, and then all of the alternate connections that go with them, and the alternate naming that they have. So we have our, if we want to set it up for SPI, you can use anything with the yellowish gold kind of color. This flesh tone, or I don't know what else it would be, but this tone here, this is all your I2C connection channels. In the light purple, we have the TX and RX channels, so those are serial connectors. So you see there is a 0 and a 1. So we actually have the ability to have more than one serial connection. These dark burgundy ones here, these are the GP ratings from Raspberry Pi. And then finally on the outside, the purple and the green are the names as listed by CircuitPython. So it gives you all the different connection attachment numbers that you might want to use. There's a lot of them. So we can still do lots with this board. It's just very crowded what's in there. There's that SWD I was talking about. These pins here, there's a special 10-pin connector you can solder on, and that'll give you full access to the debugging, or you could solder wires to individual pins if you feel tempted to do that. So let's go look at what we're going to hook up today, and we'll actually get started. This is the Feather board. We're going to be using our 8-pin Neo strip. And we're going to be connecting it to power. So we're going to take the 5 volts from the USB and we're going to use it. We're also going to hook up to ground, and then we're going to connect to pin 12 just for our signal going out to the NeoPixel strip. We're also going to be plugging in at some point. We're going to be plugging in a battery here. I'm plugging it in to this battery connection in here to show you how that works. The Raspberry Pi, it's basically the same setup but without the battery. We have our signal pin coming in way back here, which is actually on GP16. We have our common here, which is any of these square pins is a common. Any of the ones that have the square shape to the end of the pad is actually a ground connection or a common connection. And then this one here is finally the USB power way down here at the end. This takes it from V-Bus, which is actually the USB connector, so that sees the 5 volts rather than coming over to this side and grabbing the 3.3 volts. So it's the same setup on both. They're both working the same. So we can have a look at how that's working on the board. And let me just turn that picture off. Here it is here. I have these two, so I can take these two boards out of the way for now. I'll take my battery out of the way for now because it's not hooked up. And right here, I just have my little piece of reflective on there so it doesn't do that because it's awful bright. So this way you get to see those LEDs again since we figured out how to do that in the last show. And what we have here is we have the Pico up here and we have the Feather down here running the same program right now. They're almost identical, and we're actually going to see what we need to do to make that happen. And over here on the right hand side of the page, right here, I have my Pico program up and running. So let's have a look at what's in this Pico program before we build the Feather version of this. So in here, I've just started out with, this is a basic test, and that's what it is. And this is being run on a Raspberry Pi Pico. This is actually using CircuitPython, and it's version 6.2.0 beta 1. I never changed it because this is the one we used 4 weeks ago. I cleaned it up a little bit, made a couple of minor tweaks to it, but really it's the same program as what we ran before, basically. It's very, very similar. So in here, we're including our helper files. So we're including the board, the time, the digital I/O, the NeoPixels, and the random. The NeoPixels is the only one that's an extra library. You grab that from the latest library set and put that in the library folder inside of the drive. No big deal there. That one's really easy to work with. On here, I've created, this is my onboard LED. So LED is equal to digital I/O, and this is GP25. So that's what we're using there, that is the built-in one way over here. And what I'm going to do for now, I'm going to move that out of the way because I'm going to move this board out of the way. I'm going to bring this one down to the middle, and we're going to see if we can't zoom in, and let's see where it wants to be happy. We'll reposition this. And just for the sake of everybody's eyes, we'll put this back on. Let's see if I can't get that to sit on there. Well, that's pretty close to where I want it. Anyway, so it doesn't want to... Nope, wants to keep moving over. Static electricity. So here we can see that we have this going on here. That LED is up at the top there. There's that boot select button that I was talking about earlier. You can see there's much less on this board. It's not as crowded. There is a little tiny memory chip right there. And everything else is in here, including the regulator and all the other good stuff that needs to be on here. So what we're doing in this program is we're setting up the pin 25 actually is on this side of the marker. It's that little LED marked right there. It says LED. Hard to see, but it's there. And we've set it up as an output as GP25. The next thing we're going in here is we're setting up our NeoPixel object. So we set our pixel pin. I actually cleaned up the names a little bit because I didn't like it before. This is PixPin and NumPix. So I have it set up for GP16, which is in the bottom right hand where the yellow wire is connected. Number of pixels is 8. There's 8 pixels on that strip. And then we just call the strip and we call it and we assign it the pin and the number of pixels. Preset some colors. These are the same colors I used before. So I'm using here, hi guys, hello Felix, welcome. So I have my black here. I have white, red, green, blue, mauve, and then here is the array of the colors made with position in the word arrays. The positions are 0, 1, 2, 3, 4, and 5 that represent that are tied back to the 6 colors. And we're going to count black as a color, even though it's a lack of color. The strip here is strip 1 is to fill it with black, and we're setting the brightness even lower because I'm finding it's working better with this diffuser on here. So we're down to 0.1. So we're sitting at 10% brightness. So we're really low. Then we have here show the print command. So this is test. Print testing NeoPixel. Time sleep is 1. And we've got a main program, and it says while true. And it goes in here and it says column equals random range. And when the range starts at 1, goes to 6, so it's actually 1 to 5. And it's increments of 1. So 1 to 5 up here in our program is white to mauve. And then it says what it's going to do. It's going to fill it 1 position at a time. It's going to do 8 of them from 0 to 7. So that's position 0 at that far end, position 7 at this far end down here. And then basically it turns them all off again. It fills them with black and then lets it sleep for 1 second and then it repeats. And that's what it's doing. That's what we're constantly doing. So it's a pretty simple program, but it shows what we can do with the Pico. Now, what we want to look at is how do we do this with the Feather. So we'll move that one out of the way. Let's bring our Feather in to the picture. We'll get that aligned in there. And I will put that same diffuser on here so we can see it. And we can see now, oh, look at that. We're getting the glare off of the other light. There we go. So, now we can see all of those lights on there. And hopefully it won't try to refocus much because I don't put my hand in the way. So we're going to hook this one up and we're going to try it. Now, for code, I could use what's behind this little tab. But I think I'm gonna create it from scratch because I want to show you how we create this from scratch. So we're going to go here and I'm going to create a new file. And I'm going to start here right at the top. So very quickly here, we're going to say this is again, this is a basic test by me. Okay, I'm going to shorten this up here and I'm just going to put in here, this is a Feather RP2040, and I'm also going to mention in here that this is running on CircuitPython, and the version of this particular one is actually a little bit different. It's 6.2.0, which is the same part except this is running on beta 3. So this is actually running on the latest version that they have out, which the Pico will also run on. I just didn't bother updating the Pico. And it's just, we need beta 3 for the Feather. The Feather was, like I say, this particular Feather that I have sitting here, this one over here, this one here, came out of this. It's from the first production run. They did a small, I say it's the first full production run. They ran a small production run of a very small batch. They got those out into some people's hands. And the small batches, from what I hear Lady Ada said, was usually they produce like 100 of them just to get them out there and get some testing. And they did that. Then they did this, which is a larger batch, which is more of a production run. This one went out to many more people. I ordered it on Monday, got them on Wednesday. And some people did have problems. There was a little bit of a build issue with timing. So if you happen to have gotten one of these and it didn't power up properly and it doesn't save the program properly, you can either contact the customer support at Adafruit, or you can go and check out the Discord channel for Adafruit. They've actually come up and they figured out how to fix it. I was reading it this morning. They actually have it fixed and they figured out what the problem was. So some of them that were being built and tested, it was trying to speed up the particular line going to the flash, and it corrupted the file for some reason. So it didn't get done on every board, and and because they have more than one tester, it didn't get done on everybody's. Mine were fine. Other people, one person in particular who actually works for them, had one board that worked and one board that didn't, which was really handy. It helped them sort it out really quick. So the next production run, which will be their next batch going in, I imagine soon, in stock, shouldn't have that problem because they've now figured it out. So it's a minor fix. It's a little bit of flashing the chip if you've got one of the boards that didn't fire up properly, but they can do it. And it was only an issue after you powered down and powered up, which you wouldn't know until after the test. So kudos on them for figuring it out, and they'll look after you for sure if you're having an issue. Okay, the next thing I want to do when we're creating our file, we always want to include any files that we want. So we're going to include any required helper files. And we should try to spell things right. So in here, we're going to have the standard. We're going to have import board, which is pretty common for most things we're going to do. We're also going to import time, since we want to add delays and use the timing feature. We're going to import digital I/O, because that's very handy for us, because we're going to be using a pinned output to send that data to the Neopixels. Let's see, what else are we going to need here? We're going to need the Neopixel, so let's import Neopixel, and I'll show you where that is. Actually, just it's NeoPixel, all lowercase like that. And the other thing that we're going to do, we're actually going to import, and it's from internal, so it's not a separate file, but it's import random. So those are all going to be things we're going to import. Now, let me show you quickly where you go find these things to import it. So down here, I'm going to open up, and I'm going to open up my file manager. And I'm over here on this screen here. So what I'm going to do is I'm going to go to my documents folder. And when I do, I've got one here for CircuitPython. And down in here, I've created a libraries. This is where I go get the latest library files. You get that at circuitpython.org. And if you open this up, the libraries, I have a bunch of bundles in here. This last one's actually from last month. It was for 3.1, but it's fine. If I open that up, they're always coming out with new ones, so you can update as often as you want, or if there's a feature that's not working. I'm sure I'm going to have to get the latest one to start using this programmable I/O feature, but I'll get there. In here, they give you some folders. They give you some examples that you can use. So there's already pre-written files and there's lots of examples in this thing. There's also the libraries themselves and some requirements. And there's a README text and versions text, which it tells you the versions of all the different libraries. So if you go into here, we'll see there's lots of libraries depending what you're looking for. This list is quite long, but way down at the bottom, here it is. There's one called neopixel.mpy. MPY is nothing more than a Python file that's been compressed. So it takes up less room. It's still a Python file. They just took all the spaces out and stuff like that and crunched it down as small as it can possibly get, just so it doesn't take up as much room on your processor chip than it needs to. And this is the NeoPixel file, and where I would drag that to is I would drag that over to my G folder, and inside of there I have a folder called library. G is my Feather board. This is my drive for my Feather board. H happens to be the one for the Pico. And if you go over here, let's just show you what it looks like. This is what it looks like when I open up this file here. There is a folder called library. If I open that up, you'll see I've already brought in the file called neopixel.mpy. So that's allowed me to go in there. Hello, Bruce. Yeah, they did sell like hotcakes. I know that. We talked about that briefly. But you're probably, I don't know, for somebody who may not be familiar with doing all the flashing that's required on these boards, It's probably not a bad thing if you did, in case you got one of the bad ones, but I know that won't be a problem on the next batch. And it's not that it's bad, it just needs to be updated, and there's nothing wrong with the board. It just, the flash needs to be updated on it. So once that's done, you're good to go. So it's just a matter of one little fix and you're fine. So there's that NeoPixel file, and I've already copied that into the library folder on my CircuitPython board, which in this case is the Feather. So that's what that is. So let me turn that back off. We'll go back to our program and we'll continue working on our program up here. So we've imported all the files we need. The next thing I want to do is I want to create that standard LED object, which is pin 13 or just LED. So what I'm going to do here is I'm going to go in here and I'm going to create the onboard LED object. So I like to label this stuff when I'm typing just because it's easier for me to figure out later what I was trying to do. So I'm going to create LED, and this is part of the way CircuitPython works. For a standard output, input or output, I'm going to go digital I/O, and I actually have to put in a dot, and then I'm going to create digital in out. So this is a predefined object in there, and then we're going to give it the board location, which is going to be just be board. And luckily for us, we could put in D13 if we want, because that is pin 13 on the board, but it's also referred to as LED to make it simple, so people can remember it easier on Feather boards, on CircuitPython boards. That way you don't have to remember what it is. And then the next thing we have to do is we have to tell it is it an input or an output. So far we've said it's going to be a digital I/O pin, and we're going to use the pin LED, but we have to set the direction on it. So now we use the name that we gave it, which was LED. We're going to give it a direction. So we just type in direction equals, and then this is going to be, again, digital I/O dot, and instead of digital in and out, this is now going to be, with a capital D, direction. And then we're going to set the actual direction, and this is all in capitals, and this is output. So at this point now, we've created the LED on the board. So now we can access that LED that's on the Feather board. The other thing I want to create on here real quick is I want to actually, let's see, what do I want to do on this run? I think we're going to leave that because we're going to create the NeoPixel strip. So let's do that. So this one's going to be create the NeoPixel strip object. So that's what we're going to do here is we're going to create this object for the NeoPixel strip. Now in here I happen to call it, we can call it whatever we want, obviously. So I'm just trying to copy. I actually cleaned it up later, and I'm going to show you because I'm going to do this, but I'm going to call it, actually I think we'll use it the same as we did before. So let's do the pixel pin. This is the same way we called it in the Raspberry Pi. So pixel pin is equal to, and this is going to be board, and I have connected it to board, and this happens to be position D12. You can see the 12 on the board, it's upside down, but it's there, and it's D12. So I'm going to say that that's where the board is. And then I'm going to go into numpix. My number of pixels is equal to 8. So very similar to what we did before. The next thing I'm going to write is I'm going to create a name for it, and I'm going to call it pixels equals, and this is going to be, this is where we use the library NeoPixel. So we're going to use that library. We're going to name it inside NeoPixel. Did I spell that right? Nope. Let's do it that way. And I forgot the O. Look at that. Started thinking about it and then goofed up on all the writing. So there we go, NeoPixel. And then what we have to do is set the parameters for it. So the first thing we have to do is we have to give it the pin. So we're going to give it pix pin. Then we're going to go on to the next item. Next thing we have to do is we have to tell it how many pixels. So we're going to use numpix. And then the one thing we do in here is a lot of times in CircuitPython is we actually define whether we want it to auto-write that way. Auto-write or not. And I'm going to say false. I don't want it to auto-write. That way I can set a bunch of parameters to the lights individually and then tell them all to display at once. Yes, hello, Bruce. I see your comment there. Okay, so now we've created... Oh, one last thing while I'm here. I want to turn down the brightness of this again. So let me go neopixels.brightness. And we're going to set that equal to 0.1. We're going to, again, take it down to about 10% of the normal brightness. Just because otherwise it's blinding, and we don't need it to be blinding on these shows. In fact, most of the time you don't need it to be blinding. You'll probably run it at much less power than it needs to full out. Now, the next thing I'm going to do, I'm going to cheat here a little bit. I'm going to do a copy and paste. Because I'm actually going to copy it, and I'm going to paste it in here. And that's create my preset colors. I want that to be identical to what I used in the Pico. So that's all I've done is I'm actually using the same color palette in the same positions, and I've created the same array called colors. Now, I could have it come up with extra comments. I could have it print something on there right now, but we can jump right into the program at this point. So I'm just going to go while true. That starts my loop in CircuitPython. And what we're going to do here is we're going to create something called call random, because I want to create a random number, and I'm going to make that equal to random, and there's where I'm using the random from the import at the top from random. So that's from up here when we imported the function random, and this time we're going to give it range, because what we want to do is we want to create a random range based on some numbers. So there's our random range. And again, the same as what we did in the other program for the NeoPixel, we're going to start with 1. We're going to end 1 prior to 6, so it actually goes 1 to 5. And we're going to increment by 1s. So there it is there. And then we're going to do a for loop for I in range. So this is a for loop. So while I is within range, and by not giving it any extra parameters other than a final number, what this does for us, it gives us in this command, so the character is going to be, that's our data value is I, and the range is to 8. So it starts at 0 and goes to 7. It stops at 7. So it's 8 values from 0 to 7. And it increments by 1 because I didn't tell it to do anything else. If I wanted to do it different, I'd have to start putting in more parameters to make that happen. But the basic idea here is if you just want to count from, you want to count something and you want to have it do it 10 times, you just change the range to 10. And it'll go from 0 to 9. 0 is a valid number. So in here we're going to go pixels because that's what we named our strip. And we're just going to say pixels, and we're going to tell it to go to value I. So the first time through, when it's 0, this is going to be pixel position 0. Position 0 is closest to the wiring down here. So that's where position 0 is located. And we're just going to say it's going to be equal to bracket. How did I spell colors up there? Got to make sure it's spelled the same. I spelt it with a U. We better include the U. So we're using the Canadian spelling or the British spelling of colors. And then we have to say which one of these colors do we want it to be? Well, I want it to be a random number from 1 to 5. This is what this created, was a random number of 1 to 5. So I just put in here my column random, put my square bracket at the end, my round bracket at the end of that to finish that off. So it'll pick at random, whatever random number was picked, 1 to 5. That's what color is going to go in here, and that's what that pixel is going to be set to, is that random color. And then from there, what I'm going to do is I'm going to tell it to do a pixels.show. That's going to tell it to update the pixels. And then I want it to take a pause, and I want a time.sleep, which is like a delay command in Arduino. And we're going to set it in seconds, so I'm going to set it to 1.0 seconds. So it's 1 second. And that's the end of my loop there. Now what I want it to do is it's going to repeat this 8 times, so it's going to fill in each of those pixels like you can see in the image on the camera, is that it's doing all 8 pixels. And when it's finished, I want it to fill the pixels. And I'm going to use the fill command. And I'm going to fill it with the color black. Because I defined black up top, I can use that directly. And it's going to fill it in. It would have been the same as typing in 0 bracket, 0 comma 0 comma 0 close bracket. So it's just black. When I'm done that, I want to tell it to update. So again, I've got to use my pixels.show. This tells it to go ahead and send that information to the NeoPixel strip. And again, we're going to create a small pause at the end of this. So I'm just going to create time sleep. And I'm going to set that again for 1.0 seconds. So 1 second there. This is the whole program. So I've actually created all of this. I can actually go in here and click the check button since I'm using Mu to program. And it says here, hey, it says, hurrah. Checker turned up, no problem. So as far as it's concerned, the syntax looks okay. And that's really what we're after, is what if the syntax looks okay or not. And it says it does, so that's fine. So let's go ahead and we're going to save this. And you probably don't see this part. Let me see if I can move this. I will move this there. And let me go and turn that picture on. Okay, so now, move that over just a little bit. You can see here that it's trying to save it, and it wants to save it to drive H. Well, I don't want to save to drive H. I want to save to drive G because that's my feather. And I'm going to save it to this file here called code.py. I'm going to overwrite what's there. And I'm going to tell it, and it's just off the screen here. That's the save button, believe it or not, way down here. I'm going to hit save. And it's basically asking me, it already exists, do you want to replace it? And yes, I do. And we'll see my updated already. And it says there's not happy. So let's go find out what's not happy. So let me turn this screen. Let me turn this screen off here. And let me show you how we fix that. So let's go back up here. I'm going to open up my serial monitor. And I'm going to hit save again. And it says here there's a problem in line 19. NeoPixel. That should be right. I didn't put in a plural or anything like that. Pixpin, numpin. No attribute named NeoPixel. Well, there should be because it's right there in that import file. And I have the NeoPixel MBY in there. Look at that for a second. That's the Raspberry Pi one. This was the other one. NeoPixel. Did I save that wrong? Oh, look at that. Changing between all the pages makes it confusing. But it says I got a code error on line 19. Numpix equals 8. Pixpin equals that. I don't think I spelled NeoPixel wrong. Import NeoPixel, capital P in pixel. I think you might be right. Oh, look at that. Very good catch. Hey, look at that. You guys don't? Capital P. You got it with a capital P. So, who was that? That was Bruce. Capital in NeoPixel. Yeah, okay. Walter got that. Look at that. Felix. Yeah, maybe capital N. No, not a capital N, but capital P here. This NeoPixel refers to this particular item up here in the library, and this is within the library. I was missing the capital P. If I hit save now, we should see this board update. And there it is there. It's very slow. I have it set at 1 second. So it is extremely slow. But you can see it is actually updating. So it did work. Thank you very much. Good eyes by those people watching. I like that. They all noticed that something was wrong. And that's how simple it is to make a mistake in the air. So that's something to keep in mind when you're programming. It's not all perfect. Now, I wanted to show you just a little bit more since we've got a little bit of time. I'm going to make an improvement, 2 improvements to this program here. The first thing is that NeoPixel on the board is on all the time. That's just a status of green telling me that it's good. You know what? I want to utilize that in my program so I can use that as feedback in case I don't see this NeoPixel strip. Maybe it's mounted far away, but I can see where the board is. I can tell what color I'm projecting if I project that color onto this NeoPixel. So let's do that. Let's actually add that as another object. So we're going to do that. So up here in our program, we're going to create up here, and what we have to do is we created a NeoPixel strip object here. So let me go into here and create the onboard NeoPixel object. So we're actually going to create that single pixel, that single NeoPixel that's the onboard object. So I can do that. So first thing I'm going to have to call this one, I'm going to have to give it a different name. So I'm going to call this one NeoPin because it actually does have a pin assignment. And the pin assignment is board, just like everything else, board dot. And then in all capitals, it's NeoPixel. So if you want to address the NeoPixel on the, bonus marks. Yeah, you're right. Yeah, they're from a teacher. Yeah, good bonus marks. Yeah, from one teacher to another. Very good. So board is called NeoPixel, just like we did before when we were doing the LED name was all in capitals because it was a predefined name by CircuitPython. This is also a predefined name in CircuitPython called NeoPixel. The next thing we're going to have to do is we're going to have to give it the length of NeoPixel. So I'm going to call this NeoNum. And not mum. This is going to be, let's do it the other way. Num. And we're going to make that equal to 1 in length because there's only one NeoPixel on board. That's all there is. And then basically what we're going to do is we're going to create, same as what we did before, we're going to go Neo. And we're going to set this equal to, and again, we're going to use the similar to what we did before. We're going to use NeoPixel dot, and this time we're going to go Neo with a capital P in pixel. Okay, and then we're going to create the NeoPin, the NeoNum, and we're also going to say auto write, but I'm going to do it a little different this time. I'm going to go auto underscore write, and that's really going to make it different if I try to give it a different name. Auto write, and this time I'm going to say equals true. So I want this NeoPixel, since there's only one, I might as well have it update automatically. So I'm going to go ahead and do that. And then, of course, the last thing I want to do is I want to set the brightness of it. So I'm going to say neo.brightness. And I'm going to make that equal to 0.1, just like the other one was, to keep it nice and dim. we don't need it really bright, so let's make it nice and dim. So now what we've done is we've added that in here. So now we've created two NeoPixel objects in the same program. So you can have more than one NeoPixel strip connected. I could just as easily have a second or third strip connected to this and have them all controlled by here, as long as I create a separate object for each one of them so I can name them. So it knows which one to talk to. I'm going to use the same colors. What I'm going to change is I'm going to change when to do this. So down here, I'm still going to have my program that's going to create me a random number, because that's going to be important. But what I'm going to do is I'm now going to turn on, so after this, I'm going to turn on the NeoPixel. So I'm going to go Neo, because that's what I called that onboard NeoPixel, and I'm going to call it position 0. So it's the first NeoPixel in the group. So NeoPixel 0 is now equal to colors, and it should be a square bracket. So we're going to have to add the round bracket out in front of here. So it's going to be COL random square bracket round bracket. And what that's going to do, it's going to turn that NeoPixel on. So it's going to turn on, and then it's going to set the next 8. Now, there's no delay in there right now, so it just does it and jumps right into here. But we only need to do this once, so we don't put it in this area here. It only does it once. There's only 1 pixel. This one, there's 8 pixels, so we have to do this part 8 times. And then what we do down here is we have to clear that pixel at the end. So what we're going to do down here is we're going to add in the line at the bottom that says Neo. And I can use the fill or I can use the other. So let's use fill. I can fill all of them with black, which is the same as setting 0 equal to black. There is only the one. But I've just did it to match the pattern since I'm making them turn off. I just want to make sure both my NeoPixel strips turn off. If this is right, the same thing should be going on that's happening now, except this color will match with these colors, which it does this time through. If we let it go again, that stayed green, but those went red. So let's update this and see what happens. So I update that. Oh, there it is. It went blue to match the blue. When this one gets to the end of the strip here and they shut off, they should all shut off. And that one went green. Now when they all get to the end again and they shut off, they went to this, they went red. So they're going through the 5 different color choices and it's doing what it's supposed to do. One last little feature I'm going to add. We have an LED on this board. I can't use it to display different colors, but I can make it blink based on the number 1 through 5. So we're actually going to do that. So way back up here, we did create the LED object, so we don't have to do that. That part's already been done. We just have to utilize it. So what we're going to do is we're going to come down here, and we're going to go back into our main loop. We're going to go after the random, because we need this random number still. But I need a new block of code in here. So what I want to do is I want to blink the LED based on what the number is for the position of the color I'm setting. So let's make that happen here. So basically what I'm going to do is I'm going to use another for loop here because I'm going to have to blink it multiple times, possibly. So I'm going to say for, and I can use I again. I can use that, reuse that. It doesn't matter because it gets reset every time we call it in another routine. I in range. And then what we're going to do is we're going to set this I in range based to the column random number. So I want to know if it's going to return it. It's going to return either a 1, 2, 3, 4, or 5. So this is going to set the range to either 1, 2, 3, 4, or 5, depending on what color it happened to pick. And then what let's back that up. There, we got to put the we got to put a colon at the end, and then we come down here and we create the loop. And basically what I'm going to do is I'm going to go LED.value, and I'm going to set it to true, which means turn on the LED. I'm going to go time.sleep, And I'm going to set this to a relatively short time. So let's make this 0.1 seconds, so a tenth of a second. It'll be fast enough that we can see it. And that should have been on a new line, so let's put that on a new line. There we go. Then we're going to say LED.value because we want to make sure it shuts off. And that's equal to false. And then finally, we're going to put in another delay, time.sleep. And again, we're going to make that 0.1 seconds. And there it is. That should make it now blink. So if all this is correct, when I save this, what we're going to see happen is we're going to see the little LED that's over here. There it is up there by the number 13. There's a little LED. It's going to blink based on the colors. So if it's going to be green, it's going to blink 3 times. So let's see if we can see that on there. I'm going to come up here and I'm going to hit save. And it bounced, I don't know, 4 or 5 times. So it went to mauve. So it went 5 times. So very quickly, watch that. And then you'll see all the colors change. And it went to 4. Oh no, it went to 5 again. I was trying to count real fast. So we got mauve twice in a row. Let me just use another one of these deflectors. This one is not as heavy in color. Let me see if that helps. There, you can see it blink and then blink 3 times. You can also see the green LED there. And it only blinked once, by the looks of it. Went to white. It's not a very bright white because I got all this diffuser on it. There's 3 times for green, and that works. So we've done that. There was one item I mentioned last, which is going to be the last thing I do today, which does not involve the code, but does involve this board here. So what happens is I can hook up this battery. So I'm just going to bring this out and I'll reposition everything. We're just zooming out a bit. So we're in here. We have the ability to connect a battery to it. So what I'm going to do is I'm going to connect this battery right on the board while it's running. There it is. The battery's hooked up. That yellow light over there. We can, if I do this, you can see there's a little yellow LED up here in the corner. It's on because the battery's charging ever so slightly. But I'm going to unplug the USB connection now. Because this is Windows, and you know, and hopefully you know this. When you disconnect a USB device from Windows, it likes if you eject it first. So I'm actually going to go over and I'm going to hit eject. I'm actually doing that. In fact, if you just want to, just so you know, here it is here. I'm going to right click on there and I'm going to tell it to eject. So you can see that disappeared. There's my desktop. We've got the code back up. It's now popped up a message saying it's safe to unplug. So I'm going to unplug this. We can see it's still running, but my Neopixels aren't running. But this one is running. And when this goes here, it'll finish. And this will blink, and it's still doing what it wants to do. The problem is this power connection here is connected to USB. So what happens is the USB, well, there is no USB connected. So it's not drawing it from external power. I have the option, with only having so few pixels and having them dim, I'll run them off the 3.3 volts. So what I'm going to do very carefully is I'm going to pull out my red wire here. I'm going to plug it in over there on the red, and now I'm actually feeding that whole strip from this battery down here. So in 3.3 volt, I can now run it. There is no cable connected. The USB is disconnected from here. I can run it on this LiPo battery. This happens to be a 500 milliamp hour. You can get these as small as about 100 milliamp hours and as large, I think, for an individual one at 2,000, and then they come in a multi-pack and you can get them up to like 5,000 or maybe even more. So you could run this for quite a while on this 500 milliamp, and this would run for quite a few hours just with this. And again, all I have to do is take my USB cable here, plug it back in, and it will start charging the battery again. So that gives me the advantage of that. So that shows me now that I can use it. I can't do that with the Pico. The Pico, I actually have to disconnect it, plug in a power supply. This I could continue to run by just unplugging the USB. So if, for instance, if I needed battery backup on a circuit, this isn't connected right now, I could have it normally running off a USB, and then I've got battery backup. This LiPo here is my battery backup when my power's off. So it gives you that advantage now of being able to do something else. So I see there's a few more people there, so I'd like to thank everybody for showing up. I don't know if you have any quick questions, because we're actually finished for today. I hope I've covered a bunch of things. In a couple of weeks, I hope to be back, and I hope to talk about programmable I/O, which is one of the special features of the RP2040. And who knows, there might even be another 2040 processor that I have in the meantime. There are more coming. So we'll have other boards that are made with 2040s. The price. I don't think I ever mentioned the price. The Pico was $4 to buy it without any headers connected to it. So just like that, you get it with nothing else. That's $4. If you want the headers with it, it's $5, and you still have to solder them on. This board actually comes with the headers. It's $12. These are US prices, by the way. That's $12, but it comes with the headers, and again, you have to solder the headers on yourself. Not a hard deal. I would suggest anybody who's going to play around with electronics, get yourself a good soldering iron, look up some good notes on it, and learn how to solder electronics. Because if you do, it's going to make your life much more interesting, because there's too many times we have to make small solder connections. Doesn't take long. Like, I think I put those headers on yesterday on this board, and if I spent 2 minutes turning on the soldering iron and actually heating it up and doing it, I'd be surprised. It's very, very quick. Now, I am used to soldering, so take that with a grain of salt too. But thank you very much for attending. Thank you for all these people watching. I know Walter, Bruce, Felix, thank you for commenting in chat. I hope you guys all have a great weekend. If you're from North America, chances are you're doing the spring ahead tomorrow. Don't forget, it is time zone change. But in 2 weeks' time, we'll be back again, and I hope to be talking about programmable I/O, because there's some advantages over that rather than just doing regular outputs, and it takes more advantage of the processor chip that this RP2040 is, and will actually pull more features out of it than other chips that we've used in the past. Until next time, have fun, stay safe, and we'll see you all back in 2 weeks. Thanks very much. Don't forget, you can follow me on Twitter. I do send out messages of when I'm going to be on, and I think that about covers it. And also subscribe to YouTube. Bye for now.